Myself, Gaurav Gupta, on behalf of Atharbit ATS. And as of now, I can see like around 13 participants: Abdullah, Aman, Chaitanya, Farid, Harsh, Ibrahim, Neeraj, Nal Alvin, Pravin Sen, Rajeshwar, SB, Swaraj. Varun. Okay, that's good. So, like, this is a demo session for the upcoming batch of 5G optimization. Max to max in the month of next month of 1 month of duration, we will be covering up the all the black and white concepts of 5G technology. So this will be purely on 5G. But as you know that we have two kinds of architecture, so definitely we'll be having lots and lots of concepts of fundamental the bed of LTE technology as well. So the objective of this 5G training session will be like in order to understand the specific 5G RAN architecture and its deployment models, to master the key KPIs, counters, and interfaces for performance analysis and optimization, and to perform advanced troubleshooting and optimization of the key KPIs. So this 5G training session, we have divided into 6 modules. The 6 modules will be covering like accessibility optimization. Then second module will be for retainability optimization. Third module will be for mobility optimization. Fourth module will be for throughput optimization. Fifth will be for some of the live case studies, command line interface. And to begin with, we'll start with the architecture evolution and all those. This has been designed not just to jump on, directly on counters optimization, but we will go with the fundamental theoretical concept one by one. We will start with the architecture. Let me put my screen in. Let me share my screen. Okay. So guys, anyone can please confirm whether the screen is visible to you all?
Yes, we will.
Thank you.
Yes, it's
Yeah,
okay.
yeah,
Yeah, it's fine.
visible.
Thank you. So as I was saying, we will start with first module, which will be for architecture and performance framework, which will cover your 5G RAN overview. The G node B is the centralized unit, the distributed unit, the radio unit, the core network elements, the interfaces, the function splits. We will cover why this architecture, unlike LTE, which is fixed, this is split into 2 parts, CU and the DU, the CUPS architecture, we can say. We will be covering some key concepts like bandwidth, MIMO, subcarrier spacing. Then we will be covering standalone versus non-standalone deployment. There are some deployment strategies. What are the total strategies and what are the commercial opted by various operator day to day? We will be seeing some of the performance KPIs. I was saying module T will be covering like accessibility optimization, in which we will cover the RAS, complete RAS flow, which is the breakdown of from message 1 to message 4. That we will be covering. We will be covering some ENDC setup analysis, some of the common issues that has been encountered in day-to-day deliveries, which are related with coverage, which are related with interference, which are related with admission failures. Then we will see some of the parameter tuning concepts, like how to improve RACH, how to improve RRC. In every topic, we will be covering some of the key case studies, because as you know, 5G is much more emphasized towards case studies. Still, research are going on to find some of the new case studies. So that we'll be covering. Then, as I was saying, module 3 will be for retainability optimization, where again we will go back to our SA and NSA mode, but this time it will include the DRB drops, the data session, the PDU, which we say PDU session drop. Then we will see a few of the critical timer optimization, because in LT, I'm sure many of the guys, maximum of the guys have been supporting the LTE technology, in which you have tuned various parameters like T301, T310, T311 inactivity. Likewise, NR, we have some extension of timers like N310, N311. So those all we will study how to tune that, their ranges, the conditions where they get triggered, and how we can tune uh, for achieving improvement in retainability. Of course, we will see some of the case studies in retainability optimization also. Then in the fourth module, which will be for mobility optimization, we will start with the events, unlike the A1, A2, A3 events in LTE. The concept will be same, but as you know, 5G comes with some advanced features. So the differentiation, the extension, the new key concept, the new features that has been introduced, we will be discussing one by one. We will see the handover procedure, which is LTE also. It is divided into two phases: preparation and the execution, where the preparation is from the signaling side, transport side, and the execution goes to the radio side. That we will be discussing. Then we will see some of the advanced features that has been introduced in the mobility, like conditional handover, automatic neighbor relations, ANR, SON basically. In mobility also, we will be covering up few of the case studies. I was saying mobility 5 will be for throughput optimization, which will be very, very important. Each and every KPI is important, but as you know, the end user result should be, the speed should be, your services should be seamless, the latency should be low, and what 5G can deliver that 4G cannot deliver. Obviously, 4G is also the user penetration is high. It is fully commercial now. So why a user should opt for 5G? Why a user should purchase a 5G handset, even though he's having good speed, good services, 2G also. That will be covering. Basically, that will be covered in the case studies. So for the throughput optimization, we will see the carry aggregation. We will see rank indicators, MIMO. What are the contributions? What are the contributors for NSA throughput? We will deep study the MAC layer, PDCP, DRB layers. I've also included the KPI formulas in. See, we'll start with Ericsson system first. We will start the training program of this Ericsson system first for the 5G tech. Then after finishing up for the Ericsson system, we will be covering up the Nokia as well. So two vendors we will be covering. First from Ericsson, second from Nokia. Many of the concepts will be same only, and because you have fundamental knowledge of LTE, you're delivering also, so you will be able to correlate. This training model has been designed in such a simple language. We don't used to go in a very complex manner, because that will be so clumsy, confusing. So it will be like the concept should be on your hands, on fingertips, because the various guys prepares for interviews. So some of the key areas, you go to any organization, some of the questions are fixed, like call flow, NSA call flow, the SA call flow, architecture concepts, how the MIMO works, the differences, and of course the RAG call flow. There are some questions, which are fixed kind of. I mean, they will be asked every now and then. So you need to be, clear on those concepts. You must not be confused. So this our training module has been designed. We'll go to simplex to complex approach, and for every module, like for every KPI, the classes will be, for 2 days towards the weekend, because weekdays, of course, not possible because of the day-to-day deliveries, and because of the jobs of other people. So weekend classes, like they will be on Saturday and Sunday. Saturday the class will be on evening time from 8 to 10 p.m. And the next day, Sunday, it will be in the morning slot, like 10 to 12. Here, today is for the demo session, just to give an overview. But to start with, it will be for 2 hours Saturday and 2 hours Sunday. We will be showing the command line interface also. And after every module, this will not at all alone will be the theoretical concepts, but like for the Ericsson system or for the Nokia system, we will include all the relevant, say for example, we will be starting with Ericsson. So it will, individual module will include the relevant Ericsson counters, relevant Ericsson parameters, name of the counters, as a summary table you will be getting. So that apart from the theoretical knowledge, session will be helpful for you, when you perform some troubleshooting for any of the scenario. It will help towards finding the correct RCA, the root cause analysis, the correct diagnosis for it, and of course, ultimately you will be able to select the correct optimization step. Because as you know, see, optimization don't come with any fixed kind of rule. We can say a thumb rule. It depends on the scenario, it depends on the situation, depends on the KPI, depends on what kind of failures, what kind of drops, or what kind of failures you are encountering, then only you will be able to. Many of you are all already aware of the layer 3 messages, some on the fundamental level, some on the expert level. Still, many of would be in the learning phase. And just as a request to all the participants, that please, since the beginning of the session towards the end, try to, I'll also try my level best. We'll try to make this interaction, this session as interactive as possible. Otherwise, it will be kind of a, classroom going classes that I don't want to make that kind of situation. So questions will always be welcomed in between the discussion or towards the end. Feedbacks, how we can improve, any of the topic which you may feel like, hey, that has been missed, that you can suggest me. I'll definitely go with it. And in any of the topic, definitely we will not leave any of the important topics like load balancing. Now, the load balancing, when it will come, we will discuss that also in detail. I will not only assume that everybody knows this and that, even though people may have idea, but still, as a revision, we will be discussing each one by one. So duration will be of max to max of 1 month. We'll start with, like, as I said, the first module. This is just for your idea. This is not a session to start with. This is just to give you an overview. As I said, that module 1 will be for 5G architecture and performance framework. So as you know, talking about the architecture, we will keep in mind our LT concepts also. Like basically 3GPP release, as we all know, I will not go deep into much theoretical concept. That will not be of use. We have designed our training model, which will be like, which will be like useful in your strictly in your day-to-day delivery method. Like basic differences, I suppose people know the basic differences. Okay, let me go back to one slide. Just I'll take a pause here. Otherwise, it will be a unidirectional session. I'll take a pause. We have multiple participants, around 22. That's a good count. So any of the volunteer, just like to step in, I'll take a pause and just highlight some of the basic differences between LTE 5G. Whatever just to share the knowledge. Any of the volunteer, just like to step in. Anyone can please list some of the differences between the LTE and the NR technology. Anyone? There is no foundation, guys. Anyone can speak out. And I urge you to please speak out.
At least numerology.
Sorry,
Numerology, bandwidth.
Farid. Okay. Yeah, Farid.
Numerology, bandwidth.
Yeah. Mm-hmm.
Massive MIMO.
Massive memo. Okay, yeah.
Latency is also latency.
Central unit
Correct.
distributed
Yeah,
unit.
yeah. Right.
Central unit distributed unit SDAP protocol, mapping of the quality QFI.
Okay.
The core set.
Cool set. Okay.
Yeah. New PTRS, new signal channel PTRS, tracking basic tracking
Okay. Okay.
signal. What else? This is right now. If I
Okay,
can
yeah,
see.
no problem. Anyone else like to say? Thanks, Farid. Thanks for stepping in. Anyone else which like to highlight any of the topics that has been left? Network slicing here, somebody is writing. Praveen Singh. EMBB enhanced mobile broadband MMTC. Yeah, that's service part. Yeah, that's okay. Some of the new features that has been included that was not a part of LTE. Yeah, that's okay. So if we talk about the network architecture, so on architecture basis, the LTE is like the core network is evolved packet core and access network your E node B. In 5G, it will be G node B. G node B and which is further split into centralized unit and the digital centralized unit and the distributed unit. Sorry. And talking about the 5G the architecture, the LTE architecture is like flat. It is centralized. primarily we can say it is hardware based. But in 5G, it is like service based, or we can say edge computing or cloud RAN, virtualized network. So talking about spectrum, mainly below 3.5 gigahertz, which was for LTE. But in 5G, it has been distributed into two frequency ranges. We can say FR1 and FR2, where frequency range 1 is less than 6 gigahertz, and frequency range 2, it is for the millimeter waves, for the higher waves, 24 to 100 gigahertz. Talking about the duplex mode, and both the technologies, you have FDD as well as TDD. But in 5G, this TDD is mainly for TDD is meant to mainly for the 5G. And talking about the modulation, the coding schemes, MCS, which we say, in both the technologies, we have QPSK, we have 16 QAM, we have 64 QAM. But in 5G, it comes with the higher modulation techniques also. It is inclusion of 256 QAM also. In LTE Pro, which we can say, it is 256 QAM, but the core LTE technology doesn't go to such higher modulation schemes. It will end up to 64 QAM. But in 5G, it goes up to higher modulation scheme, 256 QAM. Talking about like multiple access, the downlink is based on OFDMA principle. In LTE, in uplink, it is based on single carrier FDMA principle. But for in 5G, in NR, new radio technology, both the downlink and uplink is based on OFDMA principle. And this point about the subcarrier spacing, subcarrier spacing in LTE is fixed of 15 kilohertz. But in 5G, you have a flexibility of the subcarrier spacing, like 15 kilohertz, 30 kilohertz in the double rate, 60 kilohertz, 120 kilohertz, 240 kilohertz. So again, a small question to the audience. Anyone, we are talking about the subcarrier spacing. It is a very, fundamental, very basic concept, but still, in order to make the awareness, in order to make it interactive, anyone can again question to the audience, small question to the audience. Can just anyone define what do you mean by subcarrier spacing? We have around 25, okay, 25%, that's good. Any volunteer, any participant, can you please define what do you mean by subcarrier spacing, SCS? I'll take a pause. The subcarrier spacing. This is not a new term, guys. Anyone, please?
Well, resource block, I mean, it's 15 or 30 or like this resource block, subcarriers of resource block.
Can you just elaborate? I mean, little bit more highlight, little bit more insight on it. The range, the value is okay, but what do you mean by subcarrier spacing? What it defines? Varun Pillai, frequency distance between two adjacent subcarriers in OFDMA, correct? More?
Spacing in frequency gap between two adjustment subcarrier.
That's okay. What was that? Abdullah. Okay. So basically, your subcarrier spacing, it defines the frequency operation between adjacent subcarriers. Rightly said. I'll just elaborate it. It defines the frequency operation between adjacent subcarriers in an OFDM based system like LTE or 5G NR. So it directly affects symbol duration. This subcarrier spacing directly affects the symbol duration, latency, and performance under mobility. So rightly said. I just completed your statement. This is for the subcarrier spacing. Okay, give me a moment, guys. And yes, we talked about the enhanced mobile band. Some of you were writing like, EMBB, and some was EMBB MMTC. So in this context, I would also like to add that 5G, as I was telling, that 5G comes with some of the advanced features, which was not part of the LTE. A lot of research has been made, what new. Obviously, any new technology comes, there should be a reason why customer will go for it. So it comes with the advanced features. We're talking about EMBB, we're talking about URLCC, we are talking about the massive machine tab and all that. So in this context, there is one more addition of an advanced feature, which is called as network slicing. So people who have started supporting in 5G, or guys who are already supporting in 5G deliveries, or you must be studying through various platforms, various docs, you might have came across this term network slicing. So what is network slicing? So network slicing, basically this advanced features in 5G, it allows operator to create multiple virtual networks on a single physical infrastructure. This advanced feature, network slicing, it allows operator to create multiple virtual networks on a single physical infrastructure, each tailored for a specific use case, QoS, which we say. Different virtual network are there assigned for providing support towards different QoS, depends on the specific use case. So this feature has been introduced, which is not part of our legacy technology, the network slicing. As I was telling that we will start with our 5G RAN architecture. You can see the simple split between which shows the difference. We have front haul, back haul from the transport part in the LT also, but here in 5G we will have the mid haul part also, because this architecture has been split into two components, mainly three components. Sorry, 5G: the CU, DU, RU, the centralized unit, the digital unit, and the radio unit, basically. And as I was saying, just go back to our topics. No, let us proceed in that. This is just for introduction. We will see some of the key interfaces. Give me a moment, guys. Interfaces, as you know, in LT, we will be having some new interfaces in 5G that will be covering. We will be covering some of our core network elements of 5G, like access mobility function, SMF, and the UPF. This is about network slicing, why it has been used, for what service types, this network slicing principle has been introduced in 5G technology, as I was saying about, because people were writing on the chat about EMBB, URLCC, that part also will be inclusion of our module. This is just a basic, flexible ranges of subcarrier spacing in 5G. We will again revise about, duplex mode, the MIMO, SCS, their ranges. Then we will come to the 5G deployment options. Before going this, again, let us make the, we will discuss about, what is the difference between the standalone architecture, what is the difference between the non-standalone architecture, that we will be discussing in detail. In this context, I would like to add some of the points. Just as a key summary, but one by one we'll be discussing. So if we talk about the non-standalone architecture, we have different deployment strategies, the way, commercially the network being rolled out. So in that, we have option 3, which is like commercially opted by like every second operator. Option 3 is the most common one through which the 5G network gets deployed, and there should be reason for it. It is non-standalone. Non-standalone means your network is not alone. It is a combination of LT as well as 5G. In NSA architecture, the core part that has been used is for the LT part, while the services has been deployed to, we can say the master unit is which is core, the brain of the network will be for LT, and the secondary unit will be for 5G technology. There will be two legs, and NSA provides an ENDC, dual connectivity network, we can say. And the reason for for being this option 3 as the popular, there are some of the few of the key reasons. Like, it is meant for the fast rollout, because operators opt for the deployment strategy. When deployment phase comes, you have a target. Customer gives you a target that, hey, I'm giving you the purchase order of these many sites, and you have this much of time duration until when my network should be ready. So definitely operator go for the option which provides you for the faster rollout. So option 3 is the most popular one, which provides help in deploying a network in a very fast-paced manner. And option 3 is popular because it reuses existing LT infrastructure. Whatever LT infrastructure which is doing, that will be reused. So there will not be much investment towards deploying 5G hardware, upgrading software for each and every site, that will be way costly. So this option 3 reuses the existing LT infrastructure. And of course, when you're using the existing LT infrastructure, your coverage will be very wide. Your coverage will be very, very wide. And 5G broadband for customers. And if we talk about the standalone architecture, in this, the basic difference is the brain of the network will be 5G only, means the core will be replaced by 5G. Unlike in NSA, the core part was like EPC, Evolved Packet Core. It will be in the new radio, it will be 5G core. The core has been replaced by 5G. And unlike which we were discussing in NSA, the popular one was option 3. Here, the SA mode, the popular deployment option will be option 2. Why? Because option 2 is meant for providing the private 5G networks, which we can term as enterprise solutions. The private 5G network enterprise solution. Option 2 is also used for running some smart factories. It is used in robotics. And only network slicing is only meant under option 2. Option 2 is the deployment strategy which uses network slicing only and only. Option 2 is also used for running some of the low latency applications. And option 2 is also used in VoNR rollout, voice over NR rollout. Okay. This we'll be covering in detail. This is just for the idea. Let us go for the next slide. Yeah. Here's some summary table. After each and every topic, we have prepared some of, this kind of summary table in order to make your fundamental concepts more clear, kind of a ready reckoner, should be on your fingertips. So after each and every topic, some kind of summary tables you'll be able to see. This is more about deployment options. Like I was saying, option 3, which will be the most popular common one opted by every second operator. Rest of the deployment strategies, and we will go with the few concepts of from simple to complex concepts of the KPIs. We will be covering KPI one by one. For that only we have divided these concepts into different modules, like for the accessibility, for the retainability, for the mobility, for the integrity. Like, as you know, accessibility, let me see the list. Okay, yeah. Accessibility, as you know, this is just a short summary table, like a ready reckoner. Accessibility, as you know, that it measures the success rate of users gaining services access after request, probability of receiving a proceed to select the signal, the very first step in the network. Retainability, as you know, nothing to know any new, but retainability, it evaluates services continuity without drop rate, radio link failures, frequency and involuntary detachments. That will be for retainability. Mobility, as you know, which evaluates the network availability to maintain service during the user movements. Integrity, which will be throughput part. Basically, integrity is meant for accessing services quality during active sessions, which mainly focus on throughput, latency, packet error rate, and for the spectral efficiency. Just the small ranges, not a new term, which you are not aware. This is just a small one-liner, but never to worry. We will be discussing in detail. Okay, just a small question to the audience, because we will, after this 5G architecture framework, let me see. Okay, still here. Okay. After this 5G architecture framework, we will start with accessibility optimization. And in accessibility, we will directly start with the RAS call flow. It's a very, very important topic. So that will be included as very first topic. Talking about RAS flow, random preamble first get assigned to the UE. That's the very first step. Now, anyone from the audience, from the participants, can simply define, this is a term, preamble, which you see, there are some terms which we come across every now and then, but nobody discuss on it because, we are so involved in our day-to-day deliveries. We just mug up our thresholds, we just tune the parameters, blah, blah, and all that. But, in this race, many of the key concepts get left behind. So we will test that also. I told that I want this session to be interactive. All other upcoming sessions should be interactive. So anyone from the participant can just simply define, not in a very detailed manner, in a fancy manner. Anyone can simply define what do you mean by a preamble. This is in the accessibility scenario. What do you mean by a preamble? What is a preamble? Anyone? Still, we have 25 guys. Apart from Farid, apart from Abdullah, apart from Varun, Praveen Singh.
I mean, you get the preamble from SRI, defined, which still have specific SRI, and you will send the physical random access channel message mod. Then you will get RAR message 2. Then message 3, RLC connection setup request if it is successful from contortion based likes. And then message 4 for contortion based resolution timer. Yeah, so first of all, you have to read the primary, secondary session, then secondary session to get the PCI, then you read mid, then SIP1. After that, you can get, the user equipment can get to how much power will send on initial preamble receiver target power like this for on message 1 power. So he knows now what's the power he has to send. So it's like this. After that, as I said, we have message 2, response message 3, which is successful as contention. So it's counted as RC connections request. Yeah, like this.
Rightly said, Farid. And signal sequence generated by Z of 2. Yeah, you got it. I was just asked. Yeah, rightly. That part also right, Praveen Singh. But in detail, we will discuss later on. I was just expecting a simple definition. Whatever you have said is correct, 100% correct. The preamble is nothing but a special known digital sequence sent by a UE to a base station. It is nothing but special known digital sequence sent by UE to a base station, G node B, over the PRAC, physical random access channel, in order to initiate the communication. That's it. Simple definition. Okay, as I said, we'll go from simple to complex. Yeah, rightly said, and thanks for highlighting that. Just a minute, guys.
Sorry, I think you put me like if you'd like me to go into more details, like if you have
No. This is just
successful. Okay, it's not successful. You can make ramping power like this and retransmission maximum transmission time. Okay.
Yeah. So earlier we were discussing about the 5G performance framework. So like if we talk about the 5G performance framework, though 5G performance is evaluated across the 3 major dimensions. Like we can pick out any parameter. We can compare it from 4G to LTE. For example, the peak data rate. Peak data rate 4G, it was meant max to max, it was targeting for 1 Gbps. If it is 1 Gbps, then 5G promises to deliver you up to 10 to 20 Gbps. Improvement is like from 10 to 20. If you talk about user experience data rate, if a user get max to max throughput of 10 Mbps, then 5G is targeting for 100 Mbps. If we talk about end-to-end latency, if the latency in LTE is in the range of 10 to 50 milliseconds, then 5G promises you to reduce that latency up to 1 millisecond. If we talk about the mobility max to max LTE, if it supports for 300 to 350 kilometers per hour, then 5G promises to support it to 500 kilometers per hour. Each and every spec, 5G promises some improvement, some enhancement. If we talk about the connection density, okay, people are coming very late. It's okay. So if we talk about connection density, so if there are 10 devices per kilometer, there will be more number of devices per kilometer in 5G. If we talk about energy efficiency, so energy efficiency in our old technology, LTE, is if it is moderate, then 5G promises you a very high energy efficiency. If we talk about reliability, if the reliability is 99.9%, then 100% reliability 5G promises. 100% very ideal situation. We know that on the ground that doesn't delivers. But as a test case on test paper, 5G delivers improvement in each and every aspect. Now there are some 5G performance enablers. Like if we talk about MIMO part. So MIMO in 5G, it is basically focused on the energy transmissions. You know that it improves coverage and throughput. We have mmWave, FR2, which we were discussing for the millimeter wave for the higher bandwidth, high services like EMBB and all that. Millimeter wave spectrum is meant for the high bandwidth like 24 to 100 gigahertz. It is for the ultra fast speeds. Network slicing we discussed, which was like virtual logical networks. That is meant for tailored services. This is based on virtual cloud concept 5G, which is we can say edge computing. So they're just processed close to the user. It provides more low latency. We have, as we know that it is the era of AI ML in network management for predictive optimization, for dynamic performance improvement. So that will be also part of, that will also be part of 5G tech. Let me check. Am I missing something? Sub-carrier spacing already we discussed. I'm just figuring out what more we can cover in this demo session. Load balancing, no, it is not point to discuss as of now. Okay, any one of you can just cite some basic difference between this FDD and TDD? A very small question, very simple question. I'll not throw any typical kind of question to all of you because you guys are well responding, seems like you're well involved. Anyone can cite differences between, FDD and TDD? If I say, like to say, just differentiate FDD, TDD in terms of spectrum, in terms of like typical use case, any other example, if you can cite. Anyone? We have some more number of audience. Okay. ZOS2 sequence that will be discussed later on, Praveen sir. Not required in a demo. Anyone of you have TDD differences, whatever you know? So from spectrum point of view, this FTD, it separates uplink and the downlink bands. But in TDD, you have a shared uplink and downlink band. Talking from a spectrum perspective, you have separate uplink and downlink bands for FDD, but talking about TDD, it uses the shared uplink and downlink band. Talking about like synchronization. So synchronization that is not required between the cells in FDD mode, while in TDD mode it is required in order to avoid interference because 5G is much focused on TDD. So talking about synchronization, which is not required between the cells in FDD mode, but it is mandatory in TDD mode in order to avoid interference. If we talk about like typical usage, so typical usage, if we say, then FDD is meant for low band coverage, and TDD is meant for the mid band high capacity. So coverage layer is meant for FDD, and capacity addition goes for TDD. If we talk, if I take example of band, so N1, is for FDD for up to 2.1 gigahertz, and N78, let's say for TDD, it supports up to 3.5 gigahertz. So this is few of the basic differences between the TDD and 5DD modes. So just going back to a topic, accessibility. Accessibility, you guys might have multiple times you have heard the word like SRB, the DRB, radio bearer, data radio bearer, signaling radio bearer. So what are DRB and the SRBs? Anyone like to say something? You can differentiate between SRB, DRB. This is not a KPI, not a counter. I'll start with, as I promised that we'll go from simple to complex. We will go by, bookish knowledge only. From bookish knowledge, we will head towards the practical implementation. So that will clear out your concepts, So the signaling radio bearer, this is for the accessibility part. For the signaling radio bearer, data radio bearer, what do you mean by SRB and the DRB? People are coming towards the end of the session. It's okay. Anyone? Farid, Roshan, Abdullah, Varun, Provincin.
Sir, it would get help to communicate between levels.
No, just can you differentiate? That is okay. That is it. Even preamble is also meant for that only. Why SRB is being used? Why DRB? How can you differentiate? One for signaling, one for data, one for data part, one for signaling part. There should be some usage, right? That's okay. So see, SRB, signaling radio bearer. So SRB, it is defined as radio bearers that are used only for the transmission of RRC and the NAS messages, because it is the word says signaling radio bearer. This radio bearer is used for the transmission of RRC and NAS messages. While if you talk about the data radio bearer, so DRBs are the radio bearers that are used to transport user plane traffic. Is used to transport the user plane traffic basically. So again back to SRB. So SRB 0, 1, 2 have been used to manage the signaling. Well, DRB is like default or dedicated. And DRB, it handles application data, each with specific QoS and security settings, which is configured by the network for efficient communication between UE and Node B. And if I cite some of the basic differences, very easy in a lame language. Let's say, take a topic of traffic. So if I talk about traffic, this ERB is meant for control and DRB is meant for the user data. The control plane goes to SRB and the user plane goes to the DRB. If I talk about the controlling messages, control. So SRB is used for your network signaling and DRB is used for application and application traffic. If I talk about establishment, so establishment for SRB, it is fundamental for the connection, mandatory for the connection, while DRB created on service needs, often alongside EPS bearers in the core. So this is just basic difference between the DRB and the SRB. And talking about the retainability, we will see, because 5G is meant for, it promised to deliver more seamless, more faster speed with good attainable throughput. So retainability, if we talk about, we will see what are the data radio bearers, data session drops as well. Basically, we will see the PDU session establishment, which is used in 5G SA and SA both, core also, AMF, SMF, UPF, and RAN part also. So PDU session will be covering up. PDU, see, packet data, there is nothing but the logical connection between UE and the 5G network, data network. This enables data transmission. PDU is fundamental mechanism for UE to access internet, voice services, other data services with the network. It manages resources for traffic efficiency and QoS. Each PDU session has a unique ID, different unique ID, which contain multiple QoS flows, which are treated differently based on service requirements. So like I promised that along with each and every session, we will see, like to start with Ericsson system, and then we'll go for Nokia system, specific Ericsson design counters and the parameters which can be used, their formulas, how they're built, how, in what scenario they can be used, that we'll be covering. I'll provide you option to take a screenshot. We have prepared some of the bullet points also So maximum things, whatever, start in a very lay manner, how any newcomer also, which is new to the technology, can understand it. So that, if you're investing in this training session, that should be fruitful. That should be actually useful to you. Not to just go with the college kind of syllabus, school kind of syllabus, but that should be useful, and that should probably aid in your day-to-day deliveries, so that you will not get stuck. Not only from the delivery perspective, but to get you ready, be ready in the interview scenario also. So this is all about the demo session. Still we have around how much? 22 participants. So any query, we'll be starting next week. We'll be starting with the accessibility, or the schedule as will be mentioned by Brajesh sir. I'm just stopping as of now because we are done with our demo session. Any of the participant like to query something, like to ask something, or to say, you're free to say. This is not like typical classroom session. I urge each and everyone to be proactive. Yes, please. Any question, any feedback, any expectation which you're keeping in mind, I'll answer to it.
Excuse me, I mean for this training sessions, you will go deeply on the Ericsson parameter and features.
Yes, definitely we'll go with that.
For each phases, like accessibility, readability, and throughput.
Yes, for each and every KPI module, we'll go with that.
And with features as well.
Yes, features as well, correct. Because multiple trials are going on, multiple trials, new things are coming, power headroom and all that. So we'll be covering all, whatever we can, the new features that has been rolled out, which I myself personally was involved in that. Any upcoming new. So features parameter, that part from Ericsson perspective, and as well as Nokia also, all will be included in that.
Okay. Is there a PDF session, PDF file for that, or just it will be within the video call?
That will be, I mean, presenting mode only. Will we go
Okay.
slide
Okay.
back for each service scenario I'll be covering up?
Yeah. Okay.
Okay.
Thanks.
And I think Brajesh sir will provide you one app also. In that app, these recording sessions will be available. So it is not like, if the session is gone, everything is gone. Some of the keynotes I'll be writing in chat. You can take screenshot. But apart from that, Brajesh sir will be providing you one app. In that, every recording, like you can see that this session is also being recorded. So every recording session already placed there. So it will be accessible to all of you.
Okay, fine. Good. I got
Right?
it. Thank you.
Yeah. Any other feedback, query, question? Any other expectation? I'll try to fulfill your, whatever your requirements in a very efficient manner. We'll try our level best, because at times we also need feedbacks. Abdullah, next lecture time, it will be conveyed, I'm not the right person. It will be conveyed either by Brajesh sir or by Deepak. That will be given to you. Brajesh sir is on the
Hello.
call, I think.
Next session will be scheduled on the Sunday, 10 o'clock. Okay. So guys, we have limited seats in this batch. Mainly our motto is to cover the hands-on training on the Ericsson system. You can enroll for the Ericsson. Afterward, if you want to learn the Nokia system, right? Okay. Also, you will get the 1 year validation, and also you will get the pager PPT where all parameters and count will be covered for the each KPIs. For summary basis, and every question separate on 5G VNR based out this one. Still, guys, any question you can ask. Gaurav is here to. The duration will be 1 month at session, so it's almost 16 to 18 hours learning hours for you. Still, any question you can ask. Yeah, Varun, nothing is free. You can, for the free of cost, YouTube is available. Okay. We are not providing any free courses. Okay. Because our course is not general purpose. Okay.
And I
Any other
expect that
question from?
I urge all these participants will be in same number, starting from the next session. Please refer to more number of friends and colleagues to be a part of it, so that we can have, the discussion will be more wider. It will be fruitful. So if like there is no other point, feedback, question, we can probably close the session, and we'll start from the next week, which will be from the beginning with the 5G architecture evolution.
Okay. Thanks to all. Thanks, Gaurav. Thanks, Deepak. Thanks to all. We'll meet on Sunday.
Okay,
Those who
thank
are
you.
interested with our team. And for the fee, for Indian candidate, it will be 12,000 for first 15 candidate, and for out of India candidate, it will be 150 USD. So take the benefit to get early enrollment. Okay. Thanks to all.
Thank you. Thanks for sparing time towards the weekend, and have a nice weekend.